Everyone, I'm Abednego Salmon student at African Institute for Mathematical Science. Today we're going to look at some assignment in statistical machine learning. And the first one is talking about the task of regression. The second one is talking about the task of classification. Yeah, we have in the first case our data. You can see here we have two columns and then two columns, and we have here the description of our data. The minimum is -1 and the median is 0, the mass is 1, so far and so on. Then here we have the scatter plot of y versus x. Then you can see here then the task is to find out the function which you match with the smallest error, and not zero error but with the smallest. Then at the end of the day, we try to solve it by classification, cross validations. We set the set of our function that as a set of polynomial function. We look at the minimum p, the degree of our polynomial, which will with what x is minimize the risk error. Then we see that at the end of the day we draw the cross validation error in function of the degree of polynomial. You see that the cross validation and the empirical risk, we can send this graph, we can share this graph in three parts. The first part where the error are decreasing, the empirical and the cross validation, and the second part where they are a little bit constant between 10 and 15, and the third part where the the error, the cross down, and the empirical risk, the cross validation error is going up. We can see that for polynomial degree less than 10, both the cross validation error and empirical risk are high, and then from 10 to this, we have the minimum value degree of p. The both of them are lower, and you can see here. Then in this case, we are in the case of underfitting, and this case is the case of the switch machine, and this case is the case of overfitting. Then we're going to draw all of this model. After finding the smallest degree, we choose the smallest degree as p is equal to 10. Then here we draw these three model: the simplest one, the sweetest one, and the complex one. We can notice here that how do they fit the scatter plot, and then we're going to check after all the difference, if the difference between these model are really significant. We just find out the post plots of the test error of each machine, and see that the simplest one has the highest error, and the optimal one has smallest, and the complex one is somewhere there. And then after that, we compute the ANOVA. We saw that the difference, we have at least two models in our models, which are the difference is really significant. Then this is the 95% confidence and the prediction band polynomial regression degree of 10. We choose the minimum degree as 10. And then after that, we see that the confidence and prediction band illustrate the reliability and boundary of the model. The green confidence band are narrower in the areas with more data, reflecting greater certainty in the model. Average predictions. However, the orange prediction band are consistently with the capturing the additional data variability in individual prediction and facing avoidable errors, especially at the extreme. You can notice there. Then this is the end of the first assignment, and the second one is the case of classical. The data we take it from the from R, and we saw that this data talking about the spam or non-spam. You can see the frequency here. The non-spam are highest, has highest frequency, and the spam are smallest frequency. Then we use four models: LDE, QDA, and naive Bayes, and FLD. And then these models, we're going to find out if there are the difference between these models are significant. We draw the box plot after doing the sharing the data into part training. We train the models and then we test them. Then we find out the errors. Then the mean of errors. Here we draw it, and then you can see that these LDA and FLD are not really statistical significative. And then at the end of the day, you can notice that these model are the same. Then they are the best model that we can use to predict our data. This is the end of the